talking about, now that we have all the details, we've got loops, we've got decisions, we've got selection, single sequential statements. Our programs are going to start to get bigger. And in order to do that, in order to have a program work effectively, we need to start breaking it up into pieces, okay? So what we're going to talk about, I don't think this is as difficult as loops, by the way, I'll have your, so we're going to be talking about what in C++ we call functions. In Java, you will call methods, okay? The names are the same, the names are different, but the idea is the same, okay? We're going to talk about two different kinds of functions, void and value returning, so that's how we'll start. And then we're going to pass data back and forth to these functions, and we call that parameters or arguments. That is all, pretty straightforward. Hopefully you did the lab yesterday where you saw how to call a function, how to return a function. The main tricky part with functions is when we pass the parameters, we have something called pass by value, pass by reference. We probably won't get to that today. But that's the little bit trickier part about dealing with functions. We're also going to talk about something called scope. And by that, we're going to talk about global variables and local variables. What do you think I mean when I talk about a global variable versus a local variable? Global means the whole program can see a variable. And we do that by declaring something before all the functions. We actually pretty much avoid global changes, okay? And then local means what? What would a local variable be in that function? So if you declare a variable within a function, it's what we call local to the function. It can only be seen then. And that's what we're going to lean towards, okay? So this is the things that we're going to talk about. The idea of breaking things into pieces is a pretty common problem-solving method. Anything we do seems very overwhelming. A lot of problems seem overwhelming to begin with. So when we tackle it, we tend to think, okay, let's worry about this part, let's worry about that part, let's worry about that part. We call this, kind of compartmentalizing or modularizing. Has anybody heard of this term modular before?
When you like take something apart with different pieces and rearrange it in different ways.
Have you heard of modular building, modular homes? Have you ever seen that? That's where they basically build the pieces at the factory, and then they put them all together at the site. So that's the same idea here. We're going to break things into pieces, and this allows us to solve problems. So so far, all our programs have been one module, but in reality, that's not the case. If you have millions and millions of lines of code, you have many different modules that you break it into. And we're also going to use a concept. So modularity is breaking a program into subprograms. And we're also going to do something called top-down, which means we start with general details, and then we get more specific as we go along, okay? A lot of people have a tendency to get caught in the weeds. Like what kind of, if you're building a house, the first thing you don't think about is what kind of molding am I going to use? That should be a later decision. So try to keep that same idea when you're solving a problem for a program, okay? Think very general. Don't get hung up on some algorithm. You can throw that into a module or a function and worry about it later. So we want to think very high level, very general, and get more and more detailed as we go along, okay? So that's what we mean by top-down design. So these two concepts go together with what we call modularity. The thing that I want you to remember that, I want you to skip to 3 here. It should be short enough to be able to understand what it does and to read and change it. It should be long enough to do what it wants to do. So basically it should be the perfect length, right? So a module one of the things that helps us with a modular function is what the name is. So if a modular function, and I can't emphasize this enough, if a function is called print menu, guess what that function should do? And nothing else. Just print the menu, right? So the name should correspond to what it is that function does. So don't try to do too much, okay? You can always break it into other modules or functions. The other thing that, so this is kind of goes with this. The other thing that we're going to strive for with our functions is single entry. That's what happens by default. It's pretty hard not to have a single entry function. But I want you to remember something else as we look at some functions. Single exit. Get out in one place. Because there is a return statement that can allow you to exit multiple places. And it's something we try to avoid. We can't always but we try to avoid. So single entry, single exit makes a good function. Okay, and I'll show you what I mean by that as we move along. Okay, so one of the, as I mentioned, keep subdividing. You know, you may have multiple, excuse me, multiple levels of functions, right? You start off, you have a main, and then need something to print a menu, and need something to do with the operations. That may have 3 functions that it calls. So do you see how you can break it into multiple modules? The idea of a black box is not the same thing as a plain black box. But if you think of a black box, when we talk about designing systems, that is basically an entity that does something that we don't know how it does it. So my television is essentially a black box. I don't know how the television works inside. I don't care. But I know how to operate it, and I know what I expect it to do for me. But the actual innards are not my concern. When you design a function, it should ultimately be a black box. Don't have some trick going on that the user should know about. Just let the user knows how to call it, the user knows what to expect. It does its job, it doesn't have anything hidden that happens behind the scenes. Okay, that the user should need to know about. If a function says that it's going to calculate the average, that's what it should do. There should be no trick. Nothing is happening beside that. And the user doesn't need to care how it happens. So that's what I mean about black box. Now this other idea, and I really want you to remember this as you move along in programming, one of the problems with programming is it takes a lot longer than you think, okay? And I learned this lesson, I remember in college, you know how you can write it, well, allegedly, you can write an English paper and then write words too, okay? Obviously it's crap, but, you know, we've all done that, okay? If you let this happen with programming, you are screwed, okay? Because it won't work, it won't run, okay? So one of the lessons that I learned the hard way, and one of the lessons that I think is something that's probably takes with you with programming, first of all, you can't let go of the block. You'll just learn this one day. The program won't run. But always start with something small and keep it working, okay? And I call this a dummy module. Like you may have to write a function that calculates the factorial or something, whatever, okay? Just make a dummy module. You can even say, not yet implemented, but have it there, and then keep your program running with that module in place as in the structure, so it's still running, it's still compiling, and then you can add to it that functionality when you get to it, all right? So this is a trick that you move along to 236 and 237, and further from there, keep these dummy modules that, every day you have something working. Okay, main's working and it calls a bunch of dummy modules. The next day, you get the first dummy module working, you get it fully implemented. The other guys are still there, they're just not fully functioning. So always keep something working, okay? It's a way to keep up your program. First of all, this actually works well in industry because I've actually been in a situation where there's some guy in the corner writing 1,000 lines of code and he's working his little tail off, but he doesn't have anything running, okay? Another guy is writing 10 lines of code. He checks it, and then he goes home. The next day he writes another 10, he checks it, he goes home. By the 10th day, he knows that if he has a problem, where's the problem? The last 10. Whereas the guy who's writing all these other lines, he might have done more work, but he doesn't know where the problem is. So keep small chunks of code working, and then add to it so you don't get lost in in this terrible thing. And the other thing is if a customer drops in, because your boss says to you, the customer's coming and he wants to see what you got. If you have a running product, it's a lot better, it's just a lot better for many reasons, right? And you may have done less work than the other guy. Always good to keep something working, even if that means using dummy modules, and then later adding the code. Does that make sense? Okay. Okay, so these are just some things as your programs get larger that help to keep your stuff more successful. I'm always a big believer that using good names, whether it be for a variable, whether it be for a function, I have like little rules I make for myself on how to name functions. So if I have a function that's called print page headings, I know what that function does, okay? If I have a function that's called calculate sales tax, it's evident what that does. Now, sometimes a function does more than it's hard to say, so I use the cheat word process. So process, test scores, kind of leaves it a little bit more open, if I'm doing more things in there, not misnaming what I'm doing. But validate input date, these are very clear names that you know exactly what the function is doing. You have less comments you have to do, and it lets you, it's going to be a better chance if you come back to that program 6 weeks later, you know exactly what it's doing. So again, using those good naming conventions. We're already using the function. We're using the function main. Main's a function. You know how we say void main or int main? Okay, that's a function. All right, we call this the main line for the driver. Okay? There's nothing really special about main except there can only be one main. And the other thing special about main is it's the first function to run. We can't have another main, and wherever we start, that's going to be the first function. Okay? This function is going to be calling other functions. It should be not long. Your main function, in my opinion, should always have a loop. Okay? And it should call. It should always look like a table of contents of what your program is going to do. All right? Because it may do nothing but have a loop and call other functions. That is totally fine. And we call that the main line or the driver. Okay? So we're already using a function when we talk about main. So here's an example of main set up. And then when I create another function, first of all, it follows main. It's not inside main. Some languages allow you to embed functions inside. C++ and Java do not. All functions must be what I call disjoint. Okay? They're all separate. They all indented at the same level. So if main, these brackets here indicate the beginning of main and the end of main. Every function has parentheses, and we're going to put arguments in there if we have them. We may not have arguments, okay? And then down below here, I've created a void function. Okay, we're going to have two different kinds of functions. Remember from the first slide, void and value returning. Void are the easiest ones to write, okay? What happens with this line right here? It jumps, calls, or invokes, jumps to line 5, or whatever this line number is, and goes to this function, executes all the lines in it. We say this is called invoking or calling the function, and then it returns to the line following the call. We did an exercise in lab yesterday. We had to see what happened as you call or invoke a function. Are there any questions about how a function is, first of all, just kind of declared, okay? So we have, here's a function called doproc1. Notice that C++ uses uppercase. Java uses lowercase for functions. Okay, so different languages have different conventions. We're going to follow the C++ convention. So our function names are going to begin with uppercase. We always put a begin bracket and an end bracket. We're going to have, as you've hopefully learned by now, ... It's not actually something. It's some line of code. Okay. So it's going to do whatever that function is supposed to do, and then it comes back to the line following the call. Any questions about setting up this function and calling or invoking the function? Everybody good with that? Okay. Now, I love my little diagrams, and because we are going to have a beginning design process now, we're going to use something called a hierarchy chart. Hierarchy charts are really simple. Don't make them harder than they are. For some reason or other, students get really caught up with this, okay? But all they do is show who calls whom. What does everything look like? The only thing you need to put in the block is the name of the function. That's it, okay? So, for example, if I was going to write a hierarchy chart for this guy right here, how many functions are there? Question. 2. There's 2 functions, right? So my hierarchy chart should have how many blocks? 2. No more than 2. So I make 2 blocks. The second guy, I'm going to just put the name doproc. What is it called? Doproc1, okay? All I have to put in the second one. Now, the only trick is, I think it's kind of dumb to put name inside a block. So instead, we're going to name what the program does. This kind of does nothing, so whatever, but do something. So we're going to call this, we're going to give a name to what this program does, which this is supposed to do anything, okay? But if I go to this, that's what that hierarchy chart looks like. And if I look at this guy, I have 3 functions, 3 void functions. Now, usually I put a brief comment of what the function does before I start it, when it doesn't have any code. So we have demo A, demo B, and demo C. So I have a block for demo A, a block for demo B, and a block for demo C. I call this program do stuff. So therefore, there's the hierarchy chart, that if I looked at this hierarchy chart, I would know what this program does. And most likely, if I'm going to change it, I'm going to go to one of the functions. I may not change the whole thing. I'm just going to drill right down there and know what to change. Any questions so far about calling, setting up a function, and how to do a hierarchy chart? We're going to change our, remember how we did an IPO with defining the problem? When we start to do our solution now, we're going to first write a hierarchy chart, okay? And then for each one of those blocks, we're going to do a coding solution, okay? So this guy has a plan, this guy has a plan, this guy has a plan, this guy has a plan. We're using C++ for our design. So there should be code for all four. Followed by the hierarchy chart, you then write code for each one of those individual functions, okay? Now, there's another advantage which I forgot to talk about. Another advantage of breaking stuff up into modules is, let's say when you get a job and a company is assigned a problem. How do you think that happens? Do you think one person works on the problem? Let's say that you get your company gets a job to write software for the space shuttle. What happens? What happens with the company? Does one person do it?
Multiple people.
Multiple people do it. So they can't all work on the same function. So instead, they're all given different jobs, and each person writes a different function or multiple functions. And then they're all integrated together. So the other advantage of modules or functions is they allow multiple people to work in the same program. Does that make sense? Okay, so we can say, you're doing the menu portion. You're doing the, data analysis. So you'll obviously have each of you will be working on your own function. Okay, so I just forgot to say that. All right, so the first thing we're going to look at is the difference between a void and a value returning. Now, we're going to start with void functions because I believe they're easier to do, okay? We're going to use a trick when we do void functions, and then we're going to start them with a verb, okay? So if I write a function that prints a menu, rather than calling it menu, I'm going to put a verb in front of it, and I'm going to call it print menu. And that would be a void function, okay? So if I wanted to write a function that printed a menu, and let's say that I'm going to write a do while, which is pretty common to do inside a main. And one of the first things that I'm going to do in here is I'm going to print a menu, which gives me the options for whatever it is that I want to do. So if I want to create a new function, I come outside of main. I usually put a line of stars in front of it. Like, oftentimes I'll say a little description. No spell check. Okay, so if I want this guy to print a menu, I'm going to call it this guy has no arguments, but it's still going to have the parentheses here. Okay, so no arguments, but that all functions have the parentheses following it. And then all this guy is going to do, okay, so there's a void function. Notice the caps. Notice I've called it up here, okay? Now, there's something else that you have to do in C++. Let's just take that out here. Okay, so I'm going to print a menu. What should I use if I'm going to, what other structure should I use here? If I have a menu, in what should I typically use besides the do while? Okay, so I'm going to switch based on menu option. And I'm going to put a bunch of dummy modules here. So for case 1, okay, so there's the end of my switch. And then, so now I have a do add, a do subtract. So I come down here, and I'm just going to put a cout statement so I actually get here. But I'm not going to write any code yet because I'm going to make this what I call a dummy module and get the main guy working first and then worry about those other guys. So basically I just need to make 3 dummy modules that look just like this guy. And my last one. And these are what I call dummy modules because they're not really doing what I eventually want them to do. I'm just going to put them there as a placeholder and see if I can get my main line working. Now if I compile this guy, I'm going to have some errors because what it's going to say is
print menu is not known. Print menu is not known. Does everybody see that, the error that I have? So C++ requires you to do another step whenever you use a function. And basically that is something called prototyping the function before you use it. Let me show you what I mean by that. So because basically what happened when the compiler got here, what happened? It didn't know what that was. So C++ requires you to declare before you use, I don't have to do it here, I can actually, I'm going to move this after using namespace. Every function must be what we call prototyped, which basically is a promise to say it's coming later. So I need to do that to all three functions, and it just says, okay, there's a void function called do that, and it's coming later, and I need to do the same thing for that guy. So that's what we call a function prototype, and it's necessary in C++. Question. Now you notice the function itself does not have semicolons, but in the prototype, I'm just saying I have something coming and it's going to look like this, and I'm not going to put the code here because this is just a promise that it's coming. Does everybody understand what the prototypes are? Tyler? Okay, so this is a pretty typical driver. You know, let's look at main again. I want you to look at this in good detail. I don't have a lot going on in main. I print the menu. I show that it looks like a lot like a table of contents. I think switches and menus are a really nice way to start a mainline driver. This is a very elegant way of setting up this program. I know that, remember that most programming is maintenance, you know, so 80% is changing existing code. I would know that if I want to change something with multiplication, or if I want to add another option, I would just have to go to this function. I don't have to look at the other function. Okay? So it reads a little bit like a table of contents. Let's make sure that I'm right here. So I printed the menu, and if I select 1, it's going to go to addition. If I select 2, it's going to go to subtraction. If it selects 3, it's going to go to multiply. And if I select 4, it's going to quit. So I see very quickly that my main guy's working, so I'm pretty happy with myself. Okay? So I'm going to go home, you know, I'm going to stop at happy hour, and then I'm going to come in the next day. I've got a program that compiles. It's not done, but it's running. I feel pretty good. So now when I come back the next day, I'm going to tackle one of these functions here. For example, do that. Okay? So in the case of an addition program, how would I like this guy to look? Okay, they don't have any nums yet. So one of the first things I might want to do is read into numbers. Okay? So let's say I'm going to add into the addition program, I'm going to ask the user to enter 2 numbers. Is everybody with me where I am in the addition? Okay? So I'm going to say cin num1 and cin num2. I could have done it one line, but whatever. Now I need to declare num1 and num2. Where should I do that?
So we've added num1 and num2. That's only known inside do add.
Okay. So now I'm going to print the sum. Let's do this just like I'm doing a pretty main. I didn't need to do it there. Space between the declarations and and now I'm going to print out the sum. Let's actually make another variable called sum, and I'm going to print out. Okay, so I'm doing this all inside the do addition guy. I forgot to declare sum, so I need to also declare that inside here. And I'm going to choose addition because I did that one. I'm going to ask for 2 numbers, and it said the sum is 7. Now if I wanted to add echo checking in here, so let's do the addition. See how nice this is? See how pretty this program is? Okay, I'm all in the addition, so I'm going to add a 3 and a 4 this time. The sum of 3 and 4 is 7. Okay? Now, if I'm going to do subtraction, isn't this going to look very similar? So let's actually scoot the code from subtraction. So now I've just written part 2, and I'm going to enter 2 numbers, and it says the difference is -1. Now what do you notice about the first 3 lines of sum and the first 3 lines of difference? They're the same. When you find lines are the same, what could you do? Alright, so now I'm going to take, and we're going to make a function to get the two numbers. You with me? This is a step, I'm jumping to 3 steps. You up for it? Okay. So we're good, because I said we weren't going to get to pass by reference, but we are. Alright, so I'm going to make a function down here, and I'm going to call this function get nums. You with me? And I'm going to have 2 variables, and I'm not going to declare them here. I'm going to make them arguments. Look what I've done. I've actually made arguments this time. And I'm going to put, again, I told you I'm jumping 3 steps ahead. I'm going to put an ampersand for each of these because I'm actually using past. Does everybody see what get nums? Can you just take my word for it for now, and I'm going to explain this in a little bit while I have an ampersand there? Okay. But does everybody see what I've done? I've written another void function. It's got 2 arguments, num1 and num2. Okay? I don't need to declare it. Don't need to declare it because I've already declared it inside. These guys are called what? I forget. What are these guys called again? Arguments. Now, before I use this function, what do I need to do? What do we learn we need to do in C++? Prototype it. So I'm going to take this guy right here, and I'm going to prototype it up top. Notice I included the arguments when I prototyped. Are you with me? Okay. Now the next thing I need to do is in addition and subtraction, I'm going to replace this stuff. But does everybody see that I need to declare num1 and num2 in here? So I'm going to call get nums, and what's it going to do for me? Send me 2 numbers, okay? And that means I've just reduced the code here, because now I can put here what?
When I find I keep repeating the same things, make it a function, right? Make it a function. It reduces redundancy. I can put it all in place and lots of people can use it. Does everybody see that? Okay. Now, the pass by reference I've skipped around a little bit, that ampersand. Don't worry too much about that, okay? Because I'm going to try something else this time. All right? I want to, instead of writing a void function, which all these guys are, I want to make multiply a value returning function. You ready? Okay? So what I'm going to do is I'm going to say, get rid of the verb, and I want this to actually return the result of the multiply. So I'm going to get the numbers. Okay, so let's look at this function as different. First of all, what's the first thing that's different about this function? Yeah.
Instead of void is int.
Okay, so void functions begin with verbs. They don't return anything. The second type of function is called value return. Okay? Value returning, guess what value return? You're never going to guess what a value returning function does. It returns a value. Okay? So what we have to do is select the type that the value is going to return. In this case, I'm only doing this. Another story we're going to do, we can make it float, okay, but we're just using it, okay? So since I'm returning the result of the multiply, I'm going to make that function type integer. Does that make sense? Okay? Now, since this is a value returning function, what must this sucker have before it leaves? A return statement. Value returning functions, are you with me? Value returning functions must have a return statement. Okay? Now, I'll show you the last difference, and then we're going to do some stuff at our desk because you're fading on me. Okay, so that means when I call this guy, it's different. So if it returns something, I've got to do something with what's returned. 3 different things. Here, let's look at a void again. Void is, guess what? Type void. Void has no return. And when we call a void guy, how do we call a void function? We just say the name. It may or may not have arguments. And we put semicolon return. Okay? Value returning must have a type associated with it. It must have a what?
return is the last guy, and the way we call it is also different because, there we go, you need to do something with the answer that's being returned. So here's, you see how we called this value returning function? We assigned it to something. Okay? We can't just, we have to do something with that. All right. So let's look at our sheets. We are going to use a convention. Notice a convention is not a rule. When you go get, when you go work and say, well, my teacher said that void function should have a verb. This is just a convention we're using. Nobody's going to follow it. It's just something to help you get started. Okay? So when I look at the first function there, display menu, I know that begins with a verb, so I'm going to make that function type what? Void. So then the type is void, and then the way that I would declare that function is I say void display menu, and it doesn't have any arguments. You with me? Okay. So let's look at calc squared. Let's just do whether it's void or value returning for each of them. So calc square, because of that little verb trig, is going to be what type? Void. Don't write the second part yet. That square is going to be different. Square is going to be value returning, and we can either pick what type for square. What can we pick for square? Let's pick it. Let's pick int for square. Okay? Calc sum is what type? Void. Sum is what type? Value returning. So maybe it's in, maybe it's float. Okay? Get dimensions is what type? You with me so far? Now, before we leave this page, look at the bottom of it. Okay? Let's look at the rules for void. It begins with a verb. Again, this is our convention. We can't make other programmers begin it with a verb, right? This is just how we're starting, okay? The void functions can have stuff that we return as arguments, but it doesn't return anything it doesn't have a return statement. Now, void functions are more general. They can do anything, okay? And when we call a void function, how do we call it? The main parentheses semicolon. You with me? Okay. Now let's look at value return. Value returning functions are more like the word when we think of a function, what do you think of? What's the first word that comes to your mind? Math, arithmetic functions, like sine, cosine, average, sum, these are all functions. A value returning function is like that. Okay? So it's usually a noun. It returns one single value. If it's a sum, what does it return? The sum. If it's a sine function, what does it return? The sine. See what I'm saying? Okay, it returns one value, usually mathematical. Okay, and that's the third line here. Notice what it says under value returning functions. It's usually mathematical. These are oftentimes math functions. Arithmetic. Are you with me? Okay. And then when we call it, it's different. It has to be included in one of three things: an assignment statement, a print statement. I use it a little bit here. So if you look at some of the example value returning, these all look like things you're used to in what subject? Math. If you look at some of the example void, these do a bunch of stuff. Valid AD, print menu, display header, blah, blah, blah. They're more general, right? Okay? So for right now, value returning functions are primarily going to do what? I forget. Math. Okay? All right. So let's go to the second page, and let's talk first about arguments. So let me go back to my program. Which of all these functions, let's look at the prototype, does this guy have arguments? No. Does this guy have arguments? No. So if a function can have no arguments, it can have one argument, it can have 10 arguments, there's no limit, okay? But if I declare a function to have arguments, listen carefully. If I declare it to have arguments, when I call that sucker, I better include them. So when you set up a function such as getNums, and it has two integers, when I call getNums, what do I have to include in the parentheses? Two integers. So just like in math, when you call it, your arguments must match up. If it's waiting for one argument, you have to have one argument. If it's waiting for an integer, you have to send an integer. Does that make sense?
So that argument list is our way of passing data back and forth between the functions, okay? And the type and number of arguments must match. What do I mean when I say that? The type of the arguments must match, and the number of the arguments. What do I mean by that? So if I pass if sum has been waiting for 2 integers, when I call it, what had I better pass it? 2 integers. You see what I'm saying? Okay? And there may be none. All right. So let's look at the first example.
Which is display menu, and I've already written that for you. How would you, if I was going to fill out this last column for this table, what would I put in the call to function? What would I put there?
Go ahead and fill in the call for display menu.
Now, we're going to just hop outside the box here a second. I want you to write the function calc square. So first of all, what's the type for calc square? Boy. So write that. Start your function. Okay? The way that I declare an argument is I give the type and the name just like a declaration. So if I'm passing calc square, what do you think the num is? So I'm passing to calc square the number I want to square. Does everybody see that? The second argument is square, so what do you think that is? That's the answer that I want to get back. So I'm going to have num, which is coming into the function, and I'm going to have square, which I'm actually going to put an ampersand, because that guy's going to come out of the function. Don't worry about that yet. Okay? Now, if I was going to write this is so easy to write. One line of code for this function. Yeah, that's it. That's all this guy does. Functions are short. It's the calling of them that's the issue. No new code, really. Okay, same stuff goes inside of it. It's calling it that we need to worry about, okay? Yeah, I'm just not done. Okay, so there's calc square. You with me? Any questions on how to write calc square? Cool? Square equals num times num. Okay? Now, of course, in C++, we said you need to do what with every function? So, in order for me, before I call it, I need to prototype this guy at the top. So I go up to the top, that's easy, I prototype it, put a semicolon at the end. Okay, now, I want to call this guy. So let's add a fourth menu option. First of all, I need to have a num. Well, could I just pass it a 5?
Yeah.
Who thinks I could just put, so what is calc square waiting for? I forget. What are the 2 arguments? An integer num and an integer square. Is 5 an integer? Yeah, so could I just pass it a 5 if I wanted to? That would be fine. Okay, and then the second guy could be called anything. I just need to declare it. And it's going to put the answer there for me. Questions about how I called that function. This is an integer. It could be a variable. This is a variable where I'm putting the answer, and then I'm going to print out the result afterwards. Okay, let's try writing, now I didn't print out another page, but if we continue with this exercise, we find I'm also asking you to write square. So what type of function is this, okay? What type of function is square? Value return. Okay, so how do I set it up? I didn't give you the argument, but if I'm going to square something, what do I need from it? Enough. Everybody with me? Okay? Now there's a couple different ways of doing this. But what do I know I need inside a value returning function? What do I know I need? A return. And since this guy is called square, what am I going to return?
Square.
Okay, so there's a couple different ways. One way is just to do this. Return what? I haven't figured it yet. So one way is just to say num times num. The other way is, and you might like this better, is to make a local guide called square. Say SQ equals what? And this time, what do I return instead of num times num? Does everybody see? Do you see the difference between a value just short and sweet?
It's just how you format it, right? And what did I say about these value returning? They're mostly what? Math. Mostly math. Not always. I'll show you the difference. Okay, but we're writing out the math. Okay? Give it a type. What are the arguments? Do the calculation, return answer. See how that's how most mathematical value returning functions work. Any questions? So I wanted to do difference or multiplier. Easy, right? Okay. So now the trick, where I think people get stuck, is the call. You ready? You ready for the call?
So when I call this guy, there's three different ways I can call a function. One is, first of all, I can go over and ask for a number, all right? I'm going to read in the number, and okay, so this is going to be the call. So what am I going to pass square? So this is an example of call. There's three different things you can do to a value returning function. One is to assign it to a variable. What's wrong with people? Okay, I see puzzle look. What's wrong with doing that?
Yeah, the whole idea of a value returning function is it does what? So if I call a value returning function, what is that function going to do? Return a value. It's my job to do something with that value. You see why this is wrong. Calling square that way is wrong. Because my value that was returned just got lost in space. Okay? So I have three choices. One is to assign it. So if I assign it to SQ,
Now I have the answer. Okay? That's one option. The other option is to use it. So guess what I could do right here? I could actually put the call to square right inside the print function. It'll call it, it'll get the answer back and print it right when I call it. Does that make sense? Yeah. Okay, so here's square. It has the value, it has the argument, it has the return of the answer. The call is the trick. The first option is to assign it, which I did right here. Does everybody see this call to square? The second option is to, this is the third option, this is to print it, okay? And my third option is to use it right inside an equation. So this reminds you of what? What does this remind you of? Yeah, okay, the math, right? So if I write a function that's value returning, I can plug that sucker right into the equation. So I just remembered my little ditty. Store it, use it, or print it. Sucker. The only thing I really haven't talked about, so let's go through this. Okay, so by now, you should feel comfortable with the void function. So this void function begins with a verb. It has one argument called numLines. So whoever calls this guy, how do they call print lines in this case? How would you call print lines? How do you call a void function? Print lines, and then what would have to be included in parentheses? Integer. It could be a number. It could be another variable. Okay? That's how I would call print lines. So if you look here, I've called print lines with a 2. I've called print lines with a 4. Okay? This guy is what type of function? Value returning. Notice how short the guy is. One line of code. Does it have arguments? Usually it does. It returns the value right. It has to have that as its last statement. Okay, now max is different. Okay? Let's actually hide that guy and see if you can write number 10 in this program. Look at number 10.
So first of all, what kind of function is it? Value return. So go ahead and write it. So we've got int max. Typically when we find the max, you pass in 2 numbers. So give it 2 arguments. How would you do that? Int num1, comma int num2. So what am I going to return for the max function? So if num1, so what should we have then? What should you do? Okay, you're right, but instead, then we'll end up having 2 returns, which I don't want, okay? So instead, I want you to declare in what? As soon as you get into this guy. Max, yeah, exactly, in max, okay? So now if num1 is greater than num2, what do you do instead of return? Max equals num1, else max equals num2, what are we going to return? Exactly. Now, in a second, I wonder if I type it, everybody will see it, okay? So you have 2 ways of doing it. All right? It's simple. We know all the code. If num1 is greater than num2, we could return num1. But then we're going to get into that 2 returning, which I'm not crazy about. Okay? So I'm suggesting you declare in max local to this guy, lowercase. If num1 is greater than num2, max equals what? Num1. Else, max equals, and the last line is return that. See how cool that is? Here is the function max. I declared a local max because I didn't want to have 2 return statements. Because one of the first things I said is I like them to be single entry, single exit. If num1 is greater than num2, max is num1, else max is num2, return max, voila. That's a function. Question. Okay, so I have 3 options. I could say max equals lowercase max equals max, and I could have gotten num1 from someplace. Typically, that's what I've done, right? Okay, I already know the numbers before I call max. Max equals max, num1, num2. Or I could say the maximum of num1 and num2 is, and then plug max right into the print statement. Or I could use an equation, which isn't typical for max. Okay, store it, use it, or print it. Okay, so that's a good question. So these arguments are known throughout max. They're local to max. If I want to call max, I can put it anywhere if I'm calling it main, then I need to declare num1 and num2 and main 2. And they don't have to be called num1 and num2. They can be called A and B, X and Y. All that max cares about is that you pass it 2 integers.